So we've been dealing with exponential functions where the base is any number, right? 2, 5, 0.5, 1 over 3, and so on. Well, today we're going to talk about what the natural base means. Natural base is a number called e. E is a number similar to pi, just like pi is an irrational constant. E is an irrational constant, and it's got this value. Okay? All right. We're not going to go into too much detail where e comes from, but basically, in math, this is something that shows up all the time. 1 plus 1 over x to the power of x. 1 plus 1 over x to the power of x. And a lot of times we look at, okay, what happens to this as x is infinity? So what happens if x is a million or a trillion or a billion? Well, you would think, right, you've got something to the power of a trillion, and it's going to be like this huge number. It turns out that expression just levels off to this number e. So that's where e comes from. It's not just some random number. It actually comes from a specific place. All right. You should know e at least to here, right? So 2.718, right? So if you're walking down the street and somebody asks you, hey, what's e? You should at least be able to say 2.718, okay? Well, but, you know, or you could just say 2.718. All right, so today we're going to graph using e, all right? Now, if e is 2.718, and I'm graphing e to the x, then is this an example of exponential growth or decay? It's growth, right? So since it's growth, to graph it, I use these numbers, -1, 0, 1, 2, okay? Now, the asymptote, same as before, it's going to be y equals 0, okay? The y-intercept, it's going to be e to the 0, and what's anything to the 0? 1. So it's 0, comma 1. Now, we're going to plug these in here. So basically, it's e to the -1, e to the 0, e to the 1, e to the 2. Now look. There are some of these, you can do 2 of these very quickly, because e to the 0 is what? 1. And e to the 1 is 2.718. Now to graph, I don't need to do 2.718. 2.7 is good enough. But let's plug the other ones in the calculator, because I don't know what e to the -1 is. I know it's 1 over e, right? So she says it's 0.36. So e to the -1, I totally believe you, but I just want to show how to do it on the calculator. It's 0.37. So e is, no, this one. Use the one on the ln. So second ln, right? So here, use this one, and it gives you the little exponent.
And then you do
Okay.
second, the blue button, and then you go where it says ln.
So second ln. Okay. So that's that. Now e squared, everybody knows, is 4.7. I'm sorry, 7.4. I'm sorry, 7.4, right? And we're done with the calculator. So domain, all right, I'm sorry, let's graph. The the asymptote is this. Okay. So we get at -1, 0.37. 0, we get 1. 1, 2.7. And then 7.5. Okay. And here we go. Remember, we're not connecting the dots, so you gotta show me that you're following the asymptote on the left and you're going up on the right. Okay? The domain of all exponential functions is what? All real numbers, and the range is greater than, y is greater than 0. Okay? We're good?
Yeah.
Okay. Huh?
Why is the answer y is greater than?
Because it's above the asymptote.
Oh yeah, so it's below the
Right. Okay, so it's either above or below the asymptote. So it's either y is greater than the asymptote or less than the asymptote. Okay, so e to the 2x plus 3, right? Asymptote is y equals 3. The y-intercept, e to the 0 plus 3. What's e to the 0? 1. So plus 3 is 4. The 2 doesn't change the asymptote. The only thing that change, oh, you mean for the 0, for e to the 0? It's 2 times 0, right? So it's like it's e to the 2 times 0. Okay. All right. Yes. And here I did the same thing as before. I didn't change these. So it's e to the 2x plus 3. So here it's going to be e to the 2 times negative 1, which is negative 2, plus 3. So look, when you put it in the calculator, you do second ln, whoops, negative 2, and then you exit, you press the arrow button, you exit out of that, and you got to do plus 3 underneath. Okay? I'll show you on your calculator how to do them. Okay? Yeah, as long as you're good. Yeah, 3.1. All right, here we have e to the 0 plus 3, which we just said was 4. Okay, e to the 1 plus 3. What's e to the 1? E to the 1 is 2.7 plus 3, 5.7. Oh, it's e to the 2 plus 3. I'm sorry. It's e to the 2 plus 3. Well, we just said that e to the 2 was 7.4, so this is 7.7. Okay, so can you just plug these in the Oh my God, I'm so sorry. Okay, I'm just going to plug them in. I guess my brain's not working. So what is it? 10.4. And here I have e to the 4 plus 3. E to the 4 plus 3. Yeah, and that is way too big.
Can we just use 2 or you need 3?
Okay, so it really depends. It really depends. Sometimes the numbers are so tiny and so close to each other that 2 isn't enough. So use, like, I would use 3 of them here, not the 4th one, obviously. Okay, so the asymptote is at y equals 3. And then at negative 1, we're at 3.1. Then 4. Then 10.4 right there. So, right. So the domain is all reals, and then y is greater than 3. All right? Now, I have two more. But I'm not gonna do them. You're gonna do them, and I want 2 people to come up after, like one after the other, and do them on the board. So I'm gonna stop the screencast here.